Galaxies. To the average mind, they are the largest structures in the universe. But to an astronomy student, they are much more than that. They are a complex community of stars and planets, a blur of the interstellar medium, where life is theoretically possible, although our home, the Milky Way galaxy, is the only galaxy with proven intellectual life. It is estimated that there are around 200 billion galaxies in the known universe, although we are only certain of the existence of 100 billion. The amount of galaxy types is as vast as the number of them, but there are only 4 main classifications, which are based on the arm structures. Galaxy arms are curved extensions that begin at the bulge of the galaxy, which is a spherical structure in the center of the galaxy that consists of old galactic material. Galaxy arms can range from non-existent to elongated or spiraled. Edwin Hubble was the great mind who classified the known galaxies. He developed the tuning fork diagram showing the classifications, which he believed also demonstrated the evolutionary sequence. The diagram was developed 3 centuries after the French astronomer Charles Messier first identified a galaxy. However, in the 20th century, other scientists later found Hubble's theory of the tuning fork correlation with galaxy evolution incorrect. The tuning fork diagram is easily recognizable by its simple appearance, looking similar to a 2-pronged fork, as the name suggests. The main shaft of the diagram consists of the elliptical galaxies, which are represented by the letter E, and splits into 2 spiral galaxy-type wings. The ordinary spiral galaxies are represented by an S or an SA, the barred spiral represented by an SB. The ordinary spiral galaxies are located on the top prong and the barred being on the bottom. As simple as scientists enjoy making this diagram seem, it does have a bit more depth than just a split shaft. Each type of galaxy is divided into more specific types. Ellipticals are further classified by their roundness, ranging from 0 to 7, 0 being the most round and 7 beginning to have a flat shape. These types of galaxies can be observed on the left side of the mural. At the intersection of ellipticals and spirals, there lies an SO galaxy. Characterized by their bulge and surrounding disk, these galaxies are neither a true spiral or elliptical, which is why their name is neutral. These galaxies are known as lenticular galaxies. Spiral galaxies are the most complex of classifications. Although it is still pretty simple, both the regular SA and barred SB galaxies are labeled in alphabetical order of how tight they are. SA galaxies appear having arms that are extremely close-knit and hard to discern, while having a large nuclear bulge. SC galaxies, however, have more openly structured arms and a small bulge. The difference between regular spiraled galaxies and barred spiraled galaxies is that the arms in an ordinary spiral extend directly from the center bulge, whereas in a barred spiraled galaxy, arms extend from the end of the galaxy's center. This bar is composed of stars and is the defining characteristic of barred galaxies, hence the name. Barred spiral galaxies are also classified like regular galaxies. Their arm structure is simply more intricate. Here's a fun fact. 2/3 of all spiraled galaxies are barred. Barred galaxies' arms also wind around the bar instead of the whole galaxy. There are also galaxies that have their own classification independent to the tuning fork. These are referred to as irregular galaxies. These galaxies have no specific structure to them, and they're incredibly loose. The reason we classify these as galaxies, and not nebulae, is because of the presence of a bulge. And no, size doesn't matter. A bulge is a bulge no matter how small. If you are under the impression that these galaxies are a classification of their own, you are severely mistaken and are not familiar with science, because there's always something else to learn. Irregular galaxies are actually divided into 2 subdivisions, simply named Type 1 and Type 2s. Type 1 galaxies are best described as a spiral galaxy of a peculiar form. They lack heavy elements and have a noticeable center bulge, which may or may not be centered. Type 2 galaxies are byproducts of galaxy interactions, where galactical material is ejected and forms into a relatively small galaxy. At times, these galaxy babies are still loosely attached to the main galaxy by a drawn-out arm, resembling an umbilical cord. These galaxies are parasitic and still take material from the parent galaxy.